On this little lesson, we're going to talk about the nature of the roots. When I say nature of the roots, the idea is the roots have many properties, and something controls them all. And in the last lesson, we did the quadratic equation, and there's part of that formula controls the roots. Okay, so let's talk about the graph. We know it's a parabola, which is a U-shaped. Okay, now the point where they intersect the x-axis is called the roots, or the solution to when that equals 0. This should be an equal sign. We've done it by factoring, but now we have this quadratic formula. Well, from the quadratic formula, we're going to examine part of that formula, and it's going to be used to tell me what the roots look like. It may not tell me what the roots are, but it's going to tell me what they look like. That piece is called the discriminant. Right? The discriminant, by the way, WordCheck or Microsoft Word doesn't like that word. It comes from the word discriminate. It discriminates between the different types. Once you know, when you see this part of it, you can tell what the roots are going to do. There are 4 cases. Okay, it's going to tell you, namely, if they're real or imaginary, aka you can't use them in the real number system, rational or irrational, equal or unequal. Okay, those things we're going to see just by this one number. Right, you can determine it. Okay, the discriminant is the part under the radical. It's b squared minus 4ac. Okay, so let's take a look at the 4 cases and what can happen. The first case is when you look at something like this, x squared minus 2x minus 3. The discriminant is b squared minus 4ac, so it's negative 2 squared minus 4 times 1 times negative 3. Remember, a is number there, that's b, and that's c. Right? That's 4 plus 12, which is 16. Alright, well, that's 16, big deal. I have the graph of it over here. We're going to graph it. If you do it, I gave you the graphs. It's negative 2, 1, 2, 3, 4, 5. 1, 2, 3, there's 5. And then negative 1, 0, 0, negative 3. There we go. And okay, I apparently put a domain there, so I'll just draft that piece like it says to. That is a terrible, 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 terrible graph. We need to kind of like redo that. Let's try that again. A little better. I should go right to left. I'm better that way. Alright, oof. There we go, a little better. Ugh. I got 3 more to go. Uh-oh. Notice the roots are right there and there. That's what I was trying to get it. It is at negative 1 and 3. Those are perfectly nice numbers, aren't they? Alright. Now this means this was factorable. Also, x plus 1, x minus 3. Alright. Well, the reason for that is because in the quadratic formula, negative b plus minus the square root of b squared minus 4ac all over 2a, this part is 16. Well, if you do that, the square root of 16 is 4. It's a nice number. Okay. If we look at the intercepts, they're real numbers. That's important. The second thing is they're rational. Okay. This is nice here, so that's a rational number. Actually, it's going to be, it'll be a rational number. This will be a rational number. And these will all be rational. So it's a rational over rational. It's still going to give you rational. Okay. And there's 2 of them. That's why we say they're unequal, because the plus and the minus still exists. Okay. Hits the axis twice in 2 nice rational places. Okay. And that's because the discriminant is a perfect square. Okay. So positive perfect squares are real, rational, and unequal. Real, rational, and unequal. So in other words, 2 different roots. Okay. The second one is this one. This is negative sorry, let's find the discriminant of this thing. It's b squared minus 4ac. It's negative 6 squared minus 4 times 1 times 7. It's 36 minus 28, which is a. Remember, a, b, c. Now graphing this one, now, I gave you this one as 1, 2, 2, negative 1, 3, negative 2, 4, negative 1, 5, 2. So that u does something like this. Alright? Now notice it doesn't hit in the lattice points. Ugh. That's because this, if I look in the quadratic formula, negative b plus minus square root of b squared minus 4ac over 2a, we fill it in. Well, we already know this part, we just found it. It's the square root of 8. So negative b is negative negative 6, so it's positive 6 plus minus this over 2 times 1, which is 2, which is 6 plus minus 2 radical 2 over 2. And then if we look, cancel out, we get the roots are 3 plus minus radical 2. If you look, 1, 2, 3, there's 3. This is radical 2 that way, and radical 2 that way. Okay. And they should be the same distance apart because the axis of symmetry divides it in half. Alright? And you can see they're not nice. Okay. Well, if the x-intercepts are not nice, they are irrational. That's because they got a square root in them. Right? Notice the discriminant this time is it's positive, but it's not a perfect square. And if it's not a perfect square, we're going to get something that's a little nastier. It's still going to give us 2 answers, so they're going to be unequal, 2 answers, because of the plus and the minus. We're going to have not nice numbers because the radical is still in it, so it's going to be irrational, so it's not rational anymore, but they are still real numbers. Okay. So case 2, if the discriminant is positive and not a perfect square, it'll be real, irrational, and unequal. Again, 2 roots. That means. Okay. Case 3, if you look at b squared minus 4ac, the discriminant, negative 4 squared minus 4 times 1 times 4 is 16 minus 16, which is 0. The stuff under the radical becomes 0. And if you notice, what happens? The plus and the minus, now plus minus 0 just isn't anything. It's just simply that. Right? If you graph it, it's 0 over 4 up, 1, 1, 2, 0, 3, 1, and that. And if we draw our parabola, it's going to just touch the axis. Okay. And you can see it just has one simple answer right there. It's 2. And if you look at this, the factors, look at the factors too. So the discriminant is 0. It has a real answer. It is also a rational answer. Okay? But this time we say it's equal because it's 2 both times if you look at it. So there are 2 technically, but they're the same number. Alright? So the roots will be real, rational, and equal. Okay? And I don't know why they say the discriminant is positive equals 0. It's just equal to 0. Okay, they are the same rational root, 1 root. Okay? So 0 hits the axis once. Well then, we've hit the axis twice, we can hit the axis once, and then obviously the next case is where it gets weird, is where you can hit the axis probably 0 times. Now my graph there is wrong, but if I even do it myself, you plug in 0, 1, 2, 3, 4, 5, you get 5. Plug in 1, 1 squared is 1, minus 4 is negative 3, that's 2. Plug in 2, you get 1, get this, and this. So this hits the graph, the axis 0 times, if you look at that. Okay, so that's interesting. Let's look at the discriminant. B squared minus 4ac. 1 squared minus 4. Oh, that's not b. B is negative 4. Negative 4 squared minus 4. 1 times 5. 16 minus 20 is negative 4. Negative, negative 4, negative, negative, negative. Cannot take the square roots of negatives in the real number system. Okay, So you can't take the square roots of negatives. It's never going to hit them. The roots, then, I say the discriminant is not negative, positive. It's actually less than 0, aka negative. The roots will be imaginary. Okay, and we'll have to define those roots eventually. So, to recap, if it's a perfect square, it's real, rational, and unequal. There are two roots on the graph. Okay, so we'll put over there graph hits axis. So this time it hits it 2 times because of the unequal. If it's not a perfect square, it's still real and unequal, but it's irrational. You still hit the graph in 2 places. If it's equal to 0, it's real and rational and equal this time. This one only hits it in 1 spot. And if the discriminant is less than 0, it's imaginary. So it isn't real. It can't be imaginary, rational. It's a whole other system. Right, and by the way, you hit the axis 0 times. Okay, so that's a basic recap of the discriminant. This way you can use this to help yourself.